Hello, let us solve the problem together. The method that I'm going to use to solve this integral is the method of integration by parts. So let me write and remind you the formula of integration by parts here in the beginning. So integral of u is a function of x times dv is equal to u times v minus the integral v times du. So the method of integration by parts reduces the given integral, here your question mark, to calculating a new integral with the hope that the new integral is simpler to calculate. Okay? So here I do not have that much option here. So if this is going to be solved using the integration by parts, this one should be taken to be u, and then this one should be taken dv. Of course, if you look here on the right hand side, you also need v and you also need du. So this motivates us to calculate these things as well. Okay, so let me start with calculating du. So this is my u. So this is ln of x plus square root of 1 plus x squared. And I want to differentiate both sides, so du becomes equal to, I'm going to use this formula. So you know that if you have ln of phi is any function of x, and you want to differentiate it, the answer simply becomes phi prime divided by phi itself. I won't use the same thing here. I want to give the role of phi to this expression. So this is simply x plus square root of 1 plus x squared prime, and then divided by phi itself, which is in this case the same function here, yes? Okay, so I copy and paste the denominator. By the way, I have to write dx here as well. So I copy and paste the denominator here, and then I differentiate the numerator. The derivative of x is just simply 1. Now let me also remind you about the formula here. So square root of phi is again a function of x, is equal to phi prime divided by 2 square root of phi. Yes? So here, if I want to differentiate this, I give the role of phi to 1 plus x squared. So then it becomes equal to plus phi prime, which is simply 2x, divided by 2 square root of phi, which is 2 square root of 1 plus x squared. And then you see that these 2 and that 2 are cancelled. And in the numerator, I take the common denominator. I also have to put dx. So I take the common denominator in the numerator. So it means that in the denominator, I copy and paste what I have. In the numerator, when I take the common denominator, which is 1 plus x squared, then I will get 1 plus x squared, square root of 1 plus x squared plus x. And then you see that, of course, I also have a dx here. And then you see that this expression is exactly the same expression that appears here. So they are cancelled. So finally, what is left for me is 1 over square root of 1 plus x squared dx. And this is the du that I calculated. Okay, so this is du. Okay, so I need du, I have it. I need v as well. I don't have it yet, so let me start from here. I know that dv is supposed to be dx, so this means that v is x plus any constant. And it really doesn't matter which constant you choose, so it is better to choose the constant to be 0. So that is also my v. Okay, now finally the question mark, which is integral of u dv. So let me write my question mark is equal to u times v. Okay, this is your v and this is your u. So u times v is simply x ln of x plus square root of 1 plus x squared. And then minus integral v times du. This is your v, which is x. You multiply it here by du. So this x will go into the numerator. So this becomes x over square root of 1 plus x squared dx. Okay, So you see that we reduce this integral to calculating a new integral, but I hope that you agree with me that this new integral seems simpler than the original integral here. So how should we do that? Okay, so I hope that you have enough experience now. So let me call this I, and let me write here calculating I. So how should I do that? Method of substitution. So I would say for example, let me choose a different letter. T, say, is equal to square root of 1 plus x squared. So what I do, I raise both to power 2. So this becomes t squared is 1 plus x squared. And then I differentiate both sides. And then I divide everything by 2. I get t dt is equal to x dx. Okay? So now I am looking for I, so I becomes equal to integral. Here you see x times dx, but I realize that x times dx is just simply t dt divided by this one I call the t. So now you see that this t and that t are cancelled, so I get integral of dt, which is extremely simple, and it becomes t. Of course, plus a constant, but I consider the overall constant at the very end. Okay, so let me just keep it like this. And then now instead of t, I switch back to my old variable x, so this answer becomes that one. So now finally, the problem is solved. So the question mark is this part, which is x ln of x plus square root of 1 plus x squared, and then minus I is this. And then of course finally plus an additive arbitrary constant. So this is the integral. This is the solution to this integral. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.